My friends, so today's lesson is going to focus on evaluating an expression. Now, what's great about today's lesson is that it's really going to reuse a lot of the information we just went through with our 3 lessons on order of operations. But first, before we jump into evaluating an expression, let's make sure we really understand what a variable is. We've used them a little bit so far with some of our distributing combine-like terms, but this is the first time we're actually going to be substituting for a variable. So remember that a variable is just an unknown value. All right, so we typically represent that with a letter, something like X, Y, A, B, C, D, M, N. All right, so any letter is going to be our variable, and that just represents something that's unknown at the time. All right, so we may have an expression like 3x plus 4, and you can read that as 3 times a number plus 4, or the sum of 3 times a number and 4. And so when we say a number, we're saying we just don't know what that particular thing is. So the next expression reads as a number squared minus 5, or the difference of a number squared minus 5. All right, so we're just marking that we have a value here. We're going to perform an operation or multiple operations on this value. We just don't know what it is at this point in time. Now, later in the semester, we'll eventually learn how to solve for a value, get to that unknown. All right, today what we're going to do, however, is start with an expression and then give you a value for that variable, have you plug it in, and simplify from there. So let's look at that first expression that we just had, 3x plus 4. So what's going to happen is that right now, when we have this expression, we have an unknown value. Now, what we can do is then identify a value and plug it in for that. So in this case, we're going to say, hey, what happens or what value would we get if this unknown were 2? Now, what I suggest is wherever you see this variable, all right, you put a set of parentheses, and that's what's going to happen. All right, is that we're signifying I'm taking this guy out and I'm putting this guy in. So it's basically like a substitution in basketball. All right, you're taking your starting point guard out, putting another guy in, and we're going to see what happens. So I'm going to put the 2 in right here, and notice once I do that, it is now an order of operation problem, just like what we've worked before. So I have multiplication and addition. So I do my multiplication first, and then I do my addition second. So if x is 2, our expression would simplify to 10. Now, sometimes, all right, we may be given another value. So in this case, what would happen if x were negative 4? Now, what you're going to notice is, once again, I'm going to take x out, and I'm going to put in those parentheses as a filler. All right, and I'm going to put this guy in. And so what you're going to notice is that the basics of the problem do not change. The order of operations do not change because we have the same expression. All right, so because of that, the only thing that's going to change is really the end result. So notice we still have multiplication and addition. I still have to do that multiplication first. Then I do my addition. But in the end, even though I perform the same steps in the same orders, I get a different value because I substituted in, all right, a different value at the top. All right, same kind of thing like in basketball. Maybe I'm going to down by 3. All right, I take out my center and I put my 3-point shooter on the floor. So depending on what I substitute in, all right, it's going to give me a different type of result on our problem. All right, so let's look at one more, and I'm going to work this problem twice so you can see some connections to some of the previous things we've done. All right, so first, let's look at our expression 9, and then we have times the quantity 3x minus 2. So what I could do right away is we want to know what the value of this expression will be when x is 1. So I'm going to take the x out. I'm going to put my parentheses there. And notice everything else looks exactly the same. The numbers, the parentheses, everything's exactly the same except for where this x is. We now are going to plug in a 1. Now, if we follow the order of operations, we want to simplify within our grouping symbol. I have multiplication and subtraction. So I'm going to do that multiplication first. Then I'm going to do my subtraction. And then I have my operation here, and so that leads me to 9. Now, what I was going to do second is we've talked about the distributive property. Oop, let me erase that. Copied that down wrong. Always helpful to write the problem down correctly to begin. All right. So what we talked about earlier in this unit is that we could distribute the 9 to the 3x and the 9 to the negative 2. And notice if I did that, I would get 27x and minus 18. So if you want to distribute first, that's fine. And then notice now I can substitute. So now I can take the 1 and put it in for x. Notice I still end up with multiplication and subtraction, so I do my multiplication first, then I do my subtraction, and I end up with the same number, same result. So I just wanted you to see that you can evaluate first, you can plug in, or you can distribute first and then evaluate. You will get to the same answer in the end. All right, so let's give you a chance to do one of these on your own. So go ahead and pause the video, evaluate 8a minus 2 if a is 3, and let's see how you did. All right, so let me flip to our answer here. So once again, you take the a out, we put the 3 in, perform our order of operations. So multiplication first, then subtraction, and you should get to a result of 22. All right, so now let's move on and do another one together. All right, so notice in this particular example, it's not only do we have a rational expression, all right, but we have multiple variables in that, all right, and multiple of the same variable. And so once again, if it tells us that a is -2, wherever there's an a, however many times there's an a, we're going to plug in -2. So if we look at this particular problem, notice I have a squared minus 4 in the numerator over 2 times a. So everything should look exactly the same except for where there's an a, I'm going to have a set of parentheses, and now I'm going to put in this -2. And that's really important because that really helps us manage the signs of our numbers. So for example here, this is -2 squared. So that means that's a negative times a negative, which gives me a +4. So I get 4 minus 4 in the numerator. And then here in the denominator, I have a positive times a negative, which is a -4. I do my numerator, I have one operation, so 4 minus 4 is 0. 0 divided by -4 is 0. All right, now you get to do another one. So once again, go ahead and evaluate this expression if b is -3. Pause the video and then turn it back on and see how you did. All right, so let's flip to our answer here. So once again, I'm going to take this b out. Oh, and look at that error there. Oh, not good, not good. B is -3. So let me correct this. All right, so if I put this -3 in, all right, that's going to be 4 times -3, which is -12. -12 divided by 6 is -2. Instead of getting -7, we should get -11. Apologize for that. So I type that in, and once again, it just goes to show you that that one little sign has a very big impact on the overall result of your problem. So be better than me, all right, and make sure you include that as you work through the problem. All right, so let's look at another problem here. All right, and so what happens in this one is, all right, we have an expression and we have multiple variables, all right, but now they're different variables, all right, and what we're going to do is just, once again, it's very similar, but wherever there's an x, I'm going to put in -2. Wherever there's a y, I'm going to put in +3. So in this case, I have x minus 3 divided by 5 plus 3 times y squared. So the x is -2, the y is 3. And now, once again, I'm going to go through, all right, and simplify my numerator here. All right, because remember, this is an example where those grouping symbols are implied. So -2 minus 3 is -5. So I have -5 divided by 5 plus 3 times 3 squared. Now, I have multiple operations here. I have division, I have addition, I have implied multiplication, and I have an exponent. So I'm going to take care of this exponent first. And so I get 3. And then remember, 3 squared is 3 times 3, so that's 9. Now I have division, addition, and multiplication. Now remember, division and multiplication are equivalent operations, so I do whichever one comes first, left or right. So in this case, the division, so -5 divided by 5 is 1. Bring down my addition, and then 3 times 9 is 27. All right, and then if I just extend just a little bit here, -1 plus 27 is 26. All right, so let's give you an example here, one where you have 2 different variables. So go ahead and evaluate this if a is -3 and b is 10, and then turn the video back on and see how you did. All right, so let's flip to our answers here. All right, so hopefully I'm better this time around. All right, I did get the negative in here for 3, and I did have a positive 10 here. So once again, working left to right, multiplication comes first, so I do that. Then I do my division. Now it's all addition and subtraction, so I just move left to right, and you should get to an answer of 26. Now I'm not going through step by step and explain everything in detail, but one of the reasons I have everything laid out here once again for you is so that if you need to, you can pause the video, compare your work line by line, and see if you can find any of those little mistakes, if there are any, and be able to self-correct. All right, but if there's something that you can't figure out how you missed it, be sure to bring that to my attention in class, and we'll go through it together. All right, one last problem for you. Now this is a bit of a challenge problem. Notice that I'm throwing in a root and a cube here, a cubic function here, or a cubic variable here, and see how you do. So go ahead and pause the video and evaluate this when x is 4 and y is -2. All right, let's see how you did with this. This is big time right here. Now, we haven't really talked about this. All right, so let's talk about where, all right, a root would fit into the order of operations. So we would actually consider a square root or a cube root or any form of a root as a grouping symbol, because there could be operations or an operation within that. So in this case, there's not. Okay, but it could have been x minus 2 inside or x plus 2 inside. And so if that were the case, we would treat that root like a grouping symbol to begin the problem. Now, once you're down to one number inside, like we are here, whether you begin that way or you simplify, a root would fall into the same category as an exponent, because a root and an exponent are really the same thing. This is just a rational exponent, and we'll get more to that later down the line. But as far as your order of operation goes, you would simplify a root, all right, just when you simplify your exponents. Oh, let's go back up here. There we go. All right, so square root of 4, and if I look through here, all right, square root of 4 is 2, and then notice I would do that before I do my exponent. They're equivalent operations, so I work left to right. Now I would do my exponent here, so I have negative 8. Now I have subtraction, multiplication, subtraction, multiplication, so I got to do all this multiplication first. So 4 times negative 8 is negative 32, 4 times negative 2 is negative 8. And I just went ahead and switched our signs here just to make it very clear, and then add everything up, and we get to 42. All right, so if you can handle this problem, you are really understanding a lot of the different concepts we've discussed so far in this unit. All right, so that also means you are now ready for the self-assessment and your homework, so give that a shot. Let me know if you have any questions, and I'll see you in class.